Okay, this is the last part of 6.2. In this part, we're going to be working with using functions within tables as well as graphs. A function can be represented by an input-output table and by a graph. The table and the graph below represent the function of y equals x plus 2. So you'll notice we have our inputs and our outputs here, and then they've set them up as coordinate pairs. From there, they've gone through and actually graphed it on a coordinate plane to show you that here our function, you should end up with a perfectly straight line when you do a function. So it says by drawing a line through the points, you graph all of the solutions of the function y equals x plus 2. So even though when they went through and did this, they only did 3 sets for our function, you'll notice that here's a point as well as this point that also fall in the line. Those would also be solutions to that function or that equation. Okay, so we're going to go ahead and just practice this. Once again, this will seem like a review a little bit for you, but I'm also going to tie in the words domain and range because that is something that the book previously had us work with, but did not put into play in this, actually in this part of it. So we'll come down and do that last. So here's our first situation. They want us to go ahead and use this equation. So this is going to seem very similar to what you've done before. So y equals negative 3x. So that's our function. So that's what goes into this part. I'm not going to write it every time because that's kind of a small box for me. So the inputs, we're going to pick our inputs. We're going to pick our x's. We've done this before. We did this when we did slope. Okay, we did it when we first started working with system of linear equations. So it's once again review, and then we're going to kind of tie the two pieces together. So for my inputs, I'm just going to do 0, 1, 2. Now you can do more than that. I'm just going to do 3. You do have to do at least 3. Okay, so here if I do 0 and I put 0 in place of this, negative 3 times 0 is going to give me 0 for an output. Okay, now I'll put a 1 in place of my x. Negative 3 times 1 is negative 3. Now I'm going to put a 2 in place of that. Negative 3 times 2 would give me negative 6. Ordered pairs are 0, 0, 1, negative 3, and 2, negative 6. So I'm going to graph those. So I'm going to go over to 0 up to 0, over to 1 down to negative 3, and over to 2 down to negative 6. Okay, so here's the table for that function of y equals negative 3x. Here's our graph for y equals negative 3x. And now we're going to discuss domain and range. So our domain is going to be our x values. So or our input values. What did we have for our inputs? Well, we had 0, 1, and 2. Domain, it's kind of what you start out with. It's where you originated, your domain, your house. That's where you started. And then your output is where you went out to. Okay? So then for our range, that's the same as our output. So those are our y's. So we had 0, negative 3, and negative 6. Okay, so inputs are the same as domain. Range is the same as the output, what we ranged to or where we went out to. Okay, two that are easily mixed up, but you will be assessed on that, even though it does not show up in the book. It is something that I feel that you should need to know. The previous version of the book did have it in there, so I chose to keep it. Okay, so let's go ahead and practice another one. Okay, once again, I don't feel that we need to practice a whole lot of the graphing part or the solving the equation. So we're going to focus more on the domain and range. So after this, I'll do a couple more where I throw in some inputs and outputs and we identify the domains and ranges. Okay, so here's our function. Okay, so we're going to substitute in for x's. I'll just do 0, 1, 2, 3, and 4. And now we'll substitute in. So 0 plus 1 gives me 1. 1 plus 1 gives me 2. 2 plus 1 gives me 3. You get the pattern, right? 3 plus 1 gives me 4, 5. Okay, so our inputs are the same as our domains. It's where we started, where we originate. Those are 0, 1, 2, 3, and 4. And our outputs, where we went out to, where we ranged to, That would be 1, 2, 3, 4, and 5. Okay, so if we graph these over to 0, up to 1, over to 1, up to 2, over to 2, up to 3, you can see the pattern very quickly, and then we would draw our line through that. Okay? Okay, so now I'm just going to have you practice the domain range part of it. So we're not going to have an equation right now. I'm just going to throw some numbers in here, and I want you to identify what's the domain versus what's the range. Okay, so let's say I had Okay, so I want you to go through and identify the domain and the range in those sets there. So our domain, our inputs, these are our domains, these are our ranges. So 3, 5, 7, and 9. And our ranges are our outputs, so -1, 1, 3, and 5. All right, I'm going to give you guys one more. You're going to do this one on your own. All I want you to do, you don't have to graph it and you don't have to fill in the table. All I want you to do is identify the domain and the range of the set of numbers. Okay, so go ahead, find the domain and the range sets. Pause your video, work through it, and then check back. Okay, so your domains were 5, 10, 15, and 20. Those are also known as your X's or your inputs. And your range is your output or your Y's, which were -3, 0, 3, and 6. Good luck with this part of the lesson.